Okay, the third type of factoring polynomials is factoring difference of two squares, the easiest topic, the easiest type of factoring. Now, the factor of the difference of two squares is always the product of the sum and difference of two numbers. Okay. For the given, when we say difference, the operation between the two terms should always be, or the sign between the two terms should always be a negative sign. Difference means that the operation is always subtraction. So it should be a minus sign. When we say two squares, the first term should be a perfect square. The second term is also a perfect square. Now, how to solve for the factor of the difference of two squares? Simply get the square root of the first term. Our first term in the first example is a squared. The square root of a squared is a. And next, get the square root of the second term. Our second term is 16. The square root of 16 is 4. Now, for the factor, it should always be the product of the sum and difference of the two terms. So you get the sum and difference of the square root of the first term and the second term. So the first binomial should be the sum of a and 4, and that is quantity a plus 4. This is now the sum of the two terms and the difference of the two terms, and that is a minus 4. So this is the factor of a squared minus 16. Quantity a plus 4 plus quantity times the quantity a minus 4. And it should be the product of the sum and difference of two terms. Okay, let's try number 2. The first term is 144x squared. It is a perfect square. And the second term is 49y to the 4th power. It is also a perfect square. Difference. So we have a minus sign between these two terms. So let us solve for the square root of each term. Now, what is the square root of 144x squared? Is 144 a perfect square? Yes. What is the square root? The square root is 12. Yes. How about the square root of x squared? It is x. Divide the exponent by 2, and that is x. Next, the square root of the second term. Our second term is 49. Y to the 4th. What is the square root of this term? The square root of 49 is 7. And the square root of y to the 4th, we have the exponent 4 divided by 2, and that is y squared. Now, what are we going to do with their square roots? We will get the product of their sum and difference. So, the factor should be the sum of 12x and 7y squared, and the difference of 12x and 7y squared. So the factor is 12 quantity 12x plus 7y squared plus quantity times the quantity 12x minus 7y squared plus quantity. Next. Okay, we have now example 3. We have the difference of two squares. Both terms are perfect squares. So let us solve for the square root of the first term. And what is the square root of 121 m to the 6th and to the 4th power? What is the square root of 121? The square root is 11. How about the square root of m to the 6th? The exponent of m is 6. 6 divided by 2. Okay, that is 3. Therefore, the exponent of m should be positive 3. That is 6 divided by 2 is 3. For n, we have the square root of n to the fourth, 4 divided by 2 for the exponent. It should be n to the second power. Next, second term is also a perfect square, 400 p to the 10th power and q to the 12th power. What is the square root of 400? Number that when you multiply that number by itself twice, you will get 400. What is that number? It is 20. Because 20 times 20, you will get 400. So the square root of 400 is 20. P to the 10th power, 10 divided by 2. We have P to the 5th power. And for Q to the 12th power, 12 divided by 2. We have Q to the 6th power. If these are the square roots of the first term and the last term, therefore the factor should be the sum of 11 m cubed m squared and 20 p to the 5th, p to the 6th, and the difference. You have the sum of the two terms times the difference of the two terms. So times the quantity 11 m cubed m squared minus 20, this should be m to the 5th, or p cubed rather. This should be p to the 5th power and q to the 6th power. So minus 20 p to the 5th power, q to the 6th power. So we have the product of the sum and difference of the two terms. So these are the factors of number 3. Number 4. So notice that we have a fraction. How will you solve for the square root of k squared over 25? K squared is a perfect square. 25 is also a perfect square. So solving for the square roots, that is the square root of k squared over the square root of 25. The square root of k squared is k, and the square root of 25 is 5. How about 1? 1 is a perfect square, and the square root of 1 is also 1. Therefore, what are the factors? The factors are, again, the factor should be the sum and difference. So, the first square root is k over 5. The sum of k over 5 and 1. And the second should be the difference of k over 5 and 1. So these are the factors. K over 5 plus 1 times the quantity k over 5 minus 1. Okay, last example. 8x to the 6 minus 50y to the 10th power. Is 8 a perfect square? 8 is not a perfect square. It is a perfect cube. Therefore, how will you solve for the factor? 50 is also not a perfect square. X to the 6, y to the 10th are both perfect squares because of the exponents. All the exponents are even numbers. But 8 and 50 are not perfect square. Therefore, before solving for the sum and difference, or before getting the sum and difference, you have to factor this using the first type, factoring common monomial. What is the common factor between 8 and 15? Common factor is 2. So you have to factor out 2. So greatest common factor is 2. Then we will divide each term by 2. 8x to the 6 divided by 2 is 4x to the 6. The negative 50y to the 10th power divided by 2 is negative 25y to the 10th power. So here we have now the difference of two squares. Perfect square, perfect square. then we factor out 2, since 2 is the greatest common factor. So you bring down 2, and then we will solve for the factors of this difference of 2 squares. Let us now get the square root of 4x to the 6. Since this is a perfect square, the square root is 2x to the third power. To the third power, because we divide 6 by 2, that is 3. And the square root of the second term, square root of 25y to the 10th power, is 5y to the 5th power. For the exponent of y, we divide 10 by 2, and that is 5. Therefore, the factors of 4x to the 6 minus 25y to the 10 is 2x cubed plus 5y to the 5th power. And then the other one should be 2x cubed minus 5y to the 5th power. Now, the complete factors of number 5 is 2 times the quantity 2x to the third power plus 5y to the 5th power plus quantity times 2x to the third power minus 5y to the 5th power plus quantity. That's all for today. Your questions will be entertained in our GC group chat later on. Thank you and good morning.